the most surprising part of the BMW S1000RR factory isn't the robots or the technology, it's what happens at Station 17. While most manufacturers have fully automated this critical step, BMW does something entirely different that motorcycle enthusiasts have debated for years. From raw materials to the finished superbike, we're taking you through each stage of production to reveal why the S1000RR has maintained its reputation for excellence. The truth about how these machines are built explains everything about their performance on the track. Look at those raw aluminum blocks and steel sheets arriving at the BMW factory floor. Hard to believe, isn't it? These basic industrial materials will transform into the legendary S1000RR superbike capable of delivering over 200 horsepower of pure adrenaline. What sets BMW apart begins long before assembly. The company enforces material standards that would make most manufacturers head spin. Their engineers specify metallurgical compositions with tolerances measured in parts per million, not the industry standard percentages. This obsession with material purity means that suppliers must meet specifications that are up to 3 times stricter than what's required for aerospace components. Here's something that would shock most production managers. BMW's quality control team rejects over 40% of incoming materials before they ever reach the production floor. This rejection rate would bankrupt most manufacturers, but BMW considers it essential to maintaining their performance standards. Each metal delivery undergoes spectrographic analysis to verify its exact composition, a process most competitors only sample test. As we move to the first fabrication stage, you'll see the frame components taking shape. Unlike traditional manufacturing, where cutting might happen with standard tooling, BMW employs a battery of precision lasers guided by computer systems that measure to the micron, that's 1/1000th of a millimeter. These lasers cut the frame components following 3D models that compensate for material expansion and contraction during the manufacturing process. The heart of any motorcycle is its engine, and the S1000RR starts life as a solid block of aircraft-grade aluminum. This isn't just any aluminum, it's a proprietary alloy developed specifically to handle the extreme thermal and mechanical stresses of high-performance riding. What happens next is remarkable. This block undergoes a 72-hour precision cutting process where computer-controlled machines remove metal with such precision that some internal engine passageways are finished to tolerances thinner than a human hair. While you may expect this ultra-modern facility to be fully automated, that's not the BMW way. Walking through the production floor reveals a surprising amount of human expertise at work. Each machined component, from camshafts to connecting rods, undergoes visual and tactile inspection by skilled technicians using tools that cost more than most cars. These specialists can detect surface variations as small as 2 microns simply by touch, a level of sensitivity no machine has yet matched. After passing inspection, components move to the preparation area, where they're organized into assembly groups. This isn't just about keeping parts in order. It's a precisely choreographed process where components are staged according to their thermal expansion properties, ensuring that as parts warm to operating temperature, their clearances will be exactly as designed. What truly separates BMW's manufacturing approach is this unexpected blend of cutting-edge technology and irreplaceable human craftsmanship. While competitors might tout fully automated production lines, BMW deliberately preserves human involvement at critical quality checkpoints. Their internal studies have proven that skilled technicians can still outperform automated systems when detecting subtle manufacturing anomalies that might affect performance. As we approach the first assembly stations, the motorcycle begins taking recognizable form. Engine components arrive at dedicated workstations where specialized technicians, many with over 15 years of experience, begin the meticulous process of building the power plant. Each technician is responsible for a specific assembly group, becoming an expert in that particular system, rather than a generalist working across the entire engine. The precision at this stage is astonishing. Connecting rods are weighted and matched to within 0.2 grams, equivalent to the weight of a single staple. Pistons are grouped by microscopic size variations, ensuring perfectly balanced operation at the S1000RR's 14,500 RPM redline. Nothing is left to chance. Even the torque applied to each fastener is electronically monitored and recorded. Beyond those electronically monitored fasteners lies Station 17, the heart of BMW's S1000RR S1000RR production philosophy. While most manufacturers have embraced full automation for motorcycle engine assembly, BMW maintains a seemingly contradictory approach. The most critical components of their flagship superbike are assembled by human hands. At this specialized station, a master technician with decades of experience carefully orchestrates the assembly of over 220 individual engine components. Each piece must integrate with microscopic precision to create the mechanical symphony that powers the S1000RR. The controlled environment resembles a laboratory more than a factory floor, temperature regulated to within half a degree Celsius, humidity constantly monitored, and air filtered to prevent even the smallest contaminants from interfering with the assembly process. The technicians at Station 17 are equipped with tools that might surprise even seasoned engineers. Custom machined wrenches and alignment jigs, many developed specifically for the S1000RR, cost upwards of €45,000 per set, more than the retail price of the motorcycle itself. These aren't just expensive for show. They're engineered to apply exact force and achieve alignments impossible with standard tools. We could automate this entire process, explains Klaus Müller, BMW Motorrad's head of powertrain engineering. But after extensive testing, we discovered something counterintuitive. Our master technicians consistently produce engines with performance characteristics that outperform those assembled by our automated systems. What makes this human touch so valuable becomes apparent when watching the assembly process. As the technician positions the crankshaft, they don't just follow procedure, they feel for the perfect seating. Where machines rely on programmed parameters, these specialists can detect subtle resistance that might indicate a misalignment of just 3 to 4 microns. This sensory feedback allows for micro adjustments that automated systems simply cannot replicate. Each engine receives a unique identifier, a QR code, laser etched directly onto the engine case. This digital fingerprint follows the engine throughout production and remains with the motorcycle for its entire operational life. Through BMW's service network, technicians can access the complete assembly history of any S1000RR engine, including which master technician assembled it and the exact specifications of every component. Before leaving Station 17, each engine undergoes its first crucial test, a pneumatic pressure evaluation that ensures perfect sealing of all internal chambers. Any leakage, however minor, flags the engine for immediate inspection. Only after passing this initial test is the engine cleared for the next phase of construction. Perhaps the most fascinating revelation about the S1000RR's production comes when examining its valve train assembly. This seemingly simple mechanism requires 17 distinct precision processes and 3 separate quality control checkpoints. The tolerances here are so critical that measurements are taken in microns, a unit so small that dust particles typically range from 10 to 40 microns in diameter. The valve train is where power meets precision, notes Müller. A variation of just 5 microns in valve seating can cost you 3 to 4 horsepower at high RPM. For a motorcycle operating at the limits of mechanical possibility, these microscopic differences become significant performance factors. After final inspection, the completed engine module moves along a specialized transport system to meet its counterpart, the meticulously prepared frame. This marriage is another critical moment in production, with 6 technicians simultaneously aligning and securing the power plant to its chassis, using computer-guided torque drivers that ensure perfect mounting pressure. That precisely executed engine-to-chassis marriage initiates what BMW engineers call the integration phase, where the S1000RR transforms from mechanical foundation to complete motorcycle. Standing at this juncture reveals something fascinating about modern superbike production. The greatest challenges aren't in creating powerful engines or rigid frames, but in the harmonious integration of over 1,000 individual components that must come together in a sequence so precise it cannot be altered. The final assembly represents our most complex production challenge, explains Marcus Weber, BMW Motorrad's head of final production. Each motorcycle requires exactly 1,247 components beyond the engine and frame assembly, and the installation sequence is fixed by both physical and testing requirements. What makes this phase particularly demanding is the pressure to maintain BMW's exacting standards while meeting production quotas for a motorcycle that consistently sells beyond projected volumes. The Berlin facility must produce 118 S1000RRs daily to meet global demand, allowing just 22 minutes per station for operations that would ideally take twice as long. The electrical system installation exemplifies this challenge. Technicians at Station 24 integrate the motorcycle's sophisticated electronics package, a network comprising 4.2 kilometers of wiring connecting 37 separate electronic modules. Every connection undergoes individual verification through a specialized diagnostic system that performs 142 distinct electrical tests in under 90 seconds. The electrical integration is where precision meets complexity, notes Emma Schmidt, lead electronics specialist. Our testing parameters exceed industry standards by approximately 40%. Yet we must complete verification within the production cycle time. This creates what we call the quality speed paradox. The faster we work, the more difficult it becomes to maintain our standards. Moving along the line, the bodywork installation presents its own unique demands. Each panel must satisfy dual requirements: perfect aesthetic alignment, with panel gaps maintained at exactly 3.5 millimeters throughout, while also ensuring proper airflow dynamics. The S1000RR's aerodynamic efficiency depends on panel positioning accurate to within 1 millimeter, as even slight misalignments can increase drag by up to 4% at racing speeds. The paint application on these panels employs a proprietary 3-layer process developed specifically for the S1000RR. Unlike conventional automotive finishes, the motorcycle's paint incorporates nano-ceramic particles that increase surface hardness by 60% without adding weight. This specialized coating enhances both UV and impact resistance while maintaining the distinctive visual character BMW riders expect. We apply approximately 0.8 kilograms of paint to each S1000RR, explains Dieter Hoffmann, surface finishing specialist. That might not sound like much, but it represents thousands of hours of development to create a finish that's simultaneously beautiful, protective, and lightweight. As the motorcycles progress through final assembly, technicians make real-time adjustments based on continuous feedback. The assembly process employs what BMW calls adaptive quality control, a system where measurements and testing data from completed motorcycles feed back into the production line, allowing micro-adjustments to tooling and assembly parameters for machines still in production. This adaptive approach becomes particularly crucial when addressing what production data reveals as the most persistent challenge in S1000RR assembly: maintaining perfect alignment between the bike's mechanical components and its sophisticated electronic systems during high-speed production. The motorcycle's ride-by-wire throttle system, for instance, requires synchronization between physical controls and digital sensors with a response time of under 6 milliseconds, all while being assembled in a production environment. Once assembly concludes, each S1000RR undergoes a comprehensive inspection performed by a team of 5 quality control specialists. This multi-stage assessment includes 189 individual inspection points, from functional verification of all electronic systems to visual inspection under specialized lighting that highlights even minor imperfections invisible to the naked eye. Approximately 8% of motorcycles receive additional attention before being cleared. Now we're watching the finished S1000RR take its maiden journey on BMW's 2.7-kilometer test track. Each motorcycle undergoes a rigorous 18-minute dynamic assessment where technicians evaluate 26 different performance parameters under real-world conditions. The journey from raw material to engineering masterpiece illustrates BMW's distinctive manufacturing philosophy, where cutting-edge automation meets irreplaceable human expertise. This delicate balance yields motorcycles that consistently exceed their technical specifications by measurable margins. Looking at this gleaming machine carving through the test track's final corner, it's almost impossible to imagine it began as simple aluminum blocks and steel sheets. The BMW S1000RR stands as a testament to the extraordinary possibilities when precision engineering meets passionate craftsmanship.